We talk about what is the shear shear stress and torsion test. Okay, similar to that. I mean, whatever the things that we have done so far is we were applying the force perpendicular to the area, as you can see here in this particular specimen. Yeah, this is your cross-sectional area, right? Which has been shown here in this particular graph. But now you are applying the force either in this way or in this way. Both are just perpendicular to the area, as you can see here in this diagram. You can have just dot because the your direction is coming towards the screen, right? Or into the screen or towards to out of the screen. This is the line basically. This is the point where you are applying. So if this is your area and if this is a line coming out of the screen or into the screen, what does it mean? It means it is a perpendicular to that particular area. So the in compression test or in tensile test, you are applying the load perpendicular to the area, right? But in case of the torsional or shear, what we are doing, we are applying the force parallel to the area. So if this is the kind of the bar form, okay, the material is in the form of bar, then this is your cross section area. Suppose this is your cross section area. In the above case, we have taken the circular bar. Okay, you could have the circular as well. Don't worry about that. If you think about like you can think like this is your circular bar. Okay, so this particular area, this area is your cross section. Now, instead of applying this way or this way, what you are applying the force in this way. Okay, so the the load applied is parallel to the area. Okay, which is known as your shear stress. Everything would be the same, just the application of the force is different. Okay, so if application of the force is parallel to the area means the area which is going to take a part in in the test, which means I mean you can say this is also area, this is also area. All faces of the rectangle are area or bar of area, but that area is not going to take a participate in that contact with the load. So what area that is going to take the participate in load, that is known as your cross section area. So this particular area which are going to take a participate in a load during load. So this is your cross section area. If we talk about the circular bar, then this particular area, this face of circular is going to take a part, and that is the area where the load is applied. So it depends where you have applied the force. Either if you have a rectangle, sorry, parallel, then it is a shear force or shear load. And if you have applied the force or load perpendicular to the area, then it is known as your tension or compressive. It depends on whether you are going into the material or out of the material. When force is in the pulling nature, sorry, pulling nature or pushing nature, that will define your compression and tensile. Okay. So if we talk about what the shear force, shear stress, then it is very simple. The force upon area. Okay. As you as we will discuss later, what is the stress? Stress in normal cases. If we talk about the compression test or in tensile test, in both the cases you would have the same formula. Same formula F by A. Original. This O indicate original. I mean what the area that was at the beginning of your test. Do you can think about once you start stretching the your specimen, your length will increase at the same time your diameter of the cross section area will get decrease, okay, simultaneously. So that we are not going to take into consideration that what we are taking only the original area here. That's why this all calculation is known as the true not sorry engineering stress, engineering strain, or engineering shear stress, just because we are taking only the initial value of area, okay, or better to say the cross sectional area, okay. So if as you can see, if it's just applied force, okay, in the all the cases, if means applied force and a naught is the original area, original cross section area. This simple this is written, okay. So the force in parallel to the upper and lower force. I mean, whatever the cross section area that you have, I mean, you don't need to get confused about upper and lower. You just need to think whatever the area that you have taken, okay, where you have applied the load. So that area is basically your cross section area, and that you need to focus on. Okay, so that area, if the that area is in your focus, and if the applied force is parallel to that area, then it is known as shear force. And if that force is perpendicular to that particular area, cross section area, that is known as your compressive or tensile. Depends whether the force is going into the material or out of the material. Okay, so what is I mean, the shear strain means it's the gamma. And the gamma induced similar to that of the stress strain. In the shear stress, we have the shear strain. Strain means I will let you know further.